Okay, so we're going to label this angle A, and this angle, the measure of this angle is going to be B, and we're going to draw a third angle here, the same size as B, but it'll be in standard position, and since the rotation is going to be clockwise, we'll say that this is angle negative B. Now, there is another angle that's going to be important here, and that is this angle, which is in standard position, and that angle is A plus B. Now, we know from our unit circle definition of the trig functions that on the unit circle, if an angle is in standard position, then the point where the terminal side of that angle intersects the unit circle is always the cosine of the angle, comma, the sine of the angle. Those are the coordinates for that point. So this, for instance, would be the cosine of A plus B, comma, sine of A plus B. And this point would be the point cosine A, comma, sine A. And this point we know is the point 1, 0. And this point would be the point cosine negative B, comma, sine negative B. So let's decrease the size of this to make a little room. Okay, so let's remember that the cosine of negative B is equal to the cosine of B by the opposite angle theorem, and by the same theorem we know that the sine of negative B is equal to negative the sine of B. So that will be useful as we go through the explanation of what's going on next. So what I would like to do now is draw a couple of chords on this unit circle, and the first chord is going to connect the point cosine A plus B, sine A plus B, with the point 1, 0. The second point will connect the points cosine A, sine A with the point cosine negative B, sine negative B. And since the size of the central angle that defines these chords is A plus B in both instances, these chords must be equal to each other. So that's the basic premise we have to work with here, that the chords that I have drawn in green here must be of equal length. So we can use the distance formula to set the lengths of these two chords equal to each other, and that's our next step. So we will have the cosine A plus B minus 1 squared plus the sine of A plus B minus 0 squared. and that is all under the square root radical. That's the distance formula that would connect this point and this point by that chord. So there'd be the length of this chord. And then the other chord, what the distance formula would give us there would be the square root of the cosine of A minus, now remember what I said here, cosine of negative B is the same thing as cosine of B. So cosine A minus cosine B, all squared, plus sine A plus sine B. And again, that changes to a plus because the sine of negative B is equal to negative the sine of B, all squared. So that would be the distance formula that would give us the length of this chord, the chord that connects the point cosine A sine A to the point cosine B negative sine B. So if we simplify here, we could actually square both sides and get rid of these square roots and then begin simplifying what's underneath the square root radical in both cases. So we would have cosine squared A plus B minus 2 cosine A plus B plus 1 plus sine squared A plus B. And that would be the left side here. And that will be equal to, again, simplifying the right-hand side of that previous step, we would end up with cosine squared A minus 2 cosine A cosine B plus cosine squared B plus sine squared A plus 2 sine A sine B plus sine squared B. Now we know that cosine squared theta plus sine squared theta is equal to 1. So as long as that angle is the same, cosine squared theta plus sine squared theta is equal to 1. So that includes when the angle is A plus B here on the left-hand side, and also we have an angle of A, cosine squared A plus sine squared A on the right-hand side, and we have an angle of B, cosine squared B plus sine squared B on the right-hand side. So once we rewrite that, our left-hand side here will be 2 minus 2 cosine A plus B, and the right-hand side, this will be a 1 plus another 1, so that's a 2, minus 2 cosine A cosine B plus 2 sine A sine B. Now we can subtract 2 from both sides. We could also divide both sides by negative 2. Dividing both sides by negative 2. And we will end up with cosine of A plus B is equal to cosine of A times cosine of B minus sine of A times sine of B. And that is what we call the sum formula for the cosine function. So we have just proven the cosine of A plus B will always be equal to the cosine of angle A times the cosine of angle B minus the sine of angle A times the sine of angle B.